In this video, we'll go over LeetCode question number 57, insert interval. Now, if you haven't already, I'd highly recommend you first watch my video on LeetCode number 56, merge intervals, as it's a very similar problem. The link is in the description, so please go check that out. Okay, now let's look at this problem. You are given an array of non-overlapping intervals, where each interval consists of a starting and ending value, and the intervals are also sorted by their starting value. You are also given an interval called new interval that, again, represents the start and end of another interval. The task is to insert new intervals into the intervals array, such that intervals is still sorted by each interval's starting value, and intervals still does not have any overlapping intervals, and will need to merge overlapping intervals if necessary. So for example, let's say this is the intervals array, and the new interval given is 6 to 7. If we visualize this on a number line, then these are all the intervals in the array. Notice that there are no overlaps and they are in sorted order. The new interval would then be over here in red. Since there are no overlaps, we can just insert the new interval in the correct position and return this array with all 5 intervals. Now what if the new interval went from 5 to 13? Then this is what it would look like. Notice that now 4 of the intervals overlap with each other in some way, so we'd have to merge them all into one. Our answer would then contain only 2 intervals. The first one is unchanged, and the second one goes from 4 to 15, since all 4 of those intervals got merged into one. So now let's look at the code and see how we can do this in Python. Let's say that this is the list of intervals, and I've indicated the index of each interval here. Let's also say that the new interval is 4, 8. The first thing we'll do is create an empty list called result, since it'll hold our final answer. We'll also initialize a variable called I to 0. I will be used to traverse the intervals list. We'll then enter 3 while loops, which represent 3 different sections of this code. For each one of these loops, we'll make sure that I is less than the length of intervals to make sure we don't go out of bounds. The first loop will iterate as long as the ending value of the ith interval, which is at index 1, is less than the starting value of our new interval. Since the intervals list has no overlaps and is in sorted order, we know that any interval that ends before our new interval starts must be located entirely before our new interval. So in that case, we'll just append that interval to our result. Once this condition becomes false, then we know that we may have hit our first overlap. So then we'll go to the second loop and start merging intervals. At this point, if the start of an interval is less than or equal to the end of our new interval, since we already know that this interval has an ending value that is greater than the start of our new interval, that must mean that the 2 intervals overlap. For example, the interval 3, 5 overlaps with our new interval 4, 8, because it starts before our new interval ends, and it ends after our new interval starts. So if that happens, we'll merge the 2 intervals. We'll do this by taking the minimum of the 2 starting values and make that the new starting value of our new interval. Then we'll take the maximum of the 2 ending values and make that the new ending value of our new interval. And we keep doing this as long as there are overlapping intervals. Once this condition becomes false, then that means all the rest of the intervals start after our new interval ends. In other words, we've now reached a point where we're supposed to insert our new merged interval. After that, the only thing left to do is to append the rest of the intervals to our result, and that's it. So now let's try walking through an example. The end of interval I is 2, and that is less than the start of our new interval, which is 4. That makes this condition true, so we can just append the interval 1, 2 to our result. Then we'll increment I and check again. The end of interval I is now 5, which is not less than 4, the start of our new interval. So now we'll have to check for a potential overlap. The start of interval I is 3, which is less than the end of our new interval, which is 8. This confirms that the interval 3, 5 overlaps with 4, 8, so let's merge them. The minimum of the 2 starting values is 3, so let's change the starting value of our new interval to 3. Next, the maximum of the 2 ending values is 8, so the ending value of new interval will just stay at 8. Then we'll increment I and check the next interval. 6 is still less than 8, so it's another overlap. The minimum of 6 and 3 is still 3, and the maximum of 7 and 8 is still 8, so new interval remains unchanged. Then let's check the next one. Here, 8 is equal to 8, which is still considered an overlap, so let's merge these two. The starting value of new interval stays at 3, but the ending value gets updated to 9. Now when we check the last interval, we see that its starting value, 12, is greater than the end of our new merged interval, which is 9. That means that there are no more overlapping intervals, so we can finally break out of this loop and append our new merged interval, 3, 9, to the result. The only thing left to do is to just append the rest of the intervals given, since we know that there are no more overlaps. So let's append 12, 16 to our result and increment I. I now equals 5, which is out of bounds, so we finished appending all the intervals. All that's left to do is return result, and we're done.